Hello students, today we will be looking at the last presentation in the series concerning 19th century, and we will be looking at one building and its impact in the modern times, that is the Crystal Palace. And again my aim will be to continue connecting what was happening in the 19th century with what happened later in the 20th and the 21st century. Why is the Crystal Palace such an important building? A building that was not designed by an architect, it was designed by a gardener, Joseph Paxton, a man who used to make glass houses that were made in that time for preserving green environment, plants and flowers, etc. during the harsh weather in England and in Europe. Now, the Crystal Palace itself turned out to be a building that has become a precursor of much of glass and steel large span structures we see in the 20th and the 21st century. And it has been a very impactful, influential building. And the building itself was just a freestanding exhibition structure. It was erected for a grand exhibition that was held in England in 1853, 1851, around 1850, 1851. And this exhibition was held to exhibit all the products that were being manufactured in the factories of Britain and to promote them amongst a mass audience. And so a very large building was required under one enclosure, and the way they achieved it was through the Crystal Palace. So therefore the Crystal Palace, being a freestanding exhibition structure, the cultural context itself, which was so important in the earlier buildings we have seen, was non-existent here. It was a totally new building typology which was dominated by engineering and based on the method of prefabricating glass houses, and including the fact that they were conscious of preserving the trees on site. So this transept that you see in the center of the building is actually where the trees are, and so they designed it accordingly. Now Le Corbusier said that this iron and glass walls of the Crystal Palace were the herald of a new age, and they were the forerunner of the high-tech architecture that was to come, that was promoted by architects like Norman Foster and Richard Rogers, etc. So if you see this central barrel vault of the Crystal Palace, and you can easily compare it visually also with the barrel vault in the Lloyds of London by Richard Rogers. Now it was a pioneering building. It became pioneering not so much for the architectural concept in it, more so it was important because of the iron and glass structure and prefabrication. It was made of prefabricated and wrought iron elements, and it was based on this glass house concept. This is the Palm House in the Royal Botanical Gardens in London. As you can see, this entire glass house is made of iron and glass. So the entire framework is of iron with glass incorporated within. And Paxton, who himself was making these glass houses as a gardener, expanded on his previous experiments with glass houses and made a monumental Crystal Palace. It was very cheap, very quick to construct, and they were able to erect the entire Crystal Palace in under 9 months, within 9 months. Now the key specifications that were given for the erection of the Crystal Palace led to a paradigm shift we observed through this building that impacted 20th, 21st century architecture. And that was, the structure had to be temporary, it had to be simple, it had to be economical, it had to be built in under a year. And it was a pioneering architectural space. In concept also, as a design concept, it was pioneering because it led to large column-free spaces which was there in the Crystal Palace, and it was also pioneering because of the idea of engineering and construction processes that it brought about. So if you look at it, it was more about the building process and not about the form. The form itself was not, what you might say, very defining for modern architecture, but the process was was defining of what was to come. Right from the initial conception to fabrication, to the shipment of the fabricated units in the factory to the site of construction. Therefore, the site of construction itself became more of an assembly site, and then finally erecting it on the site of construction. So this prefabrication in iron and glass happened, which revealed the potential of a completely new architecture, which was gigantic, large span structure in iron and glass. and it was the first comprehensive example of a prefabricated architectural building, or rather architecture on such a massive scale. Now, because there was a vast requirement of materials, the pieces that were to be installed here was subcontracted to several foundries and glass factories. One factory was not enough to supply the amount of material, for example, glass panes required here. So, they were manufactured in all these various factories, shipped to site and assembled here. All parts were prefabricated and each modular unit was self-supporting. It was a brilliant design with over 18,000 glass sheet panes which were installed per week, and all the glass was installed within 5 months. Now, how much glass was there? Each glass panel, these 18,000 panels, each glass pane at that time had a maximum of 10-inch to by 49-inch module, and so therefore it was a completely modular system. It was prefabricated and it was a modular design, because modular construction and prefabrication go together. If your units are modular, only then can you prefabricate them in a plant in an assembly line process. All the transoms, all the mullions, all the glass panes having the same size repetitively are produced in the factory, and thus they are brought on site and assembled. Therefore, modular construction and prefabrication generally go together, and this building laid the foundation of this concept for modern architecture. Now, this modular system with this grid of cast iron beams and columns led to a total length of 564 meters of the Crystal Palace, a little more than half a kilometer. Therefore, if we look at the architectural advancement, if we put it together, repeating modules were used for prefabricated cast iron elements, and even the glass panes manufactured in the plant. For the first time, the benefit of prefabricated construction of such a large scale was used. Cast iron parts were easy, fast and economical to manufacture on a large scale, so they could be manufactured quickly in a factory, more economically, and then shipped on site. Also, one added advantage was that we were manufacturing these parts under controlled conditions, so there was more accuracy and the quality of the product was ensured. So, this was a very important benefit of prefabrication. So, if you look at it in totality, first there is the design and construction, prefabricated iron and glass modules, the components manufactured off-site in factories, brought to site and assembled quickly and economically. The impact was the feasibility and efficiency of prefabricated construction for such a large project became obvious. Then reducing construction time and therefore reducing labor costs and the overall cost of the project. There was very little wastage of material, because having been prefabricated in the factory, it could be done more economically without wastage. Very little on-site wet work was needed at all, and large scale flexible designs were possible. Now, because of this one building, there was a huge impetus towards prefabrication in architecture, particularly in World War I and World War II in the early 20th century, because during the World Wars there was a need of rapid construction of military facilities and post-war housing, and therefore prefabrication became essential for these types of buildings. They could be made very quickly, they could be made very efficiently. As we move on, and during this period, I mean just a little before the wars also, and during and after that period also, lot of other notable developments. For example, what came to be known as mail order prefabricated homes. Many companies in America came up with this idea. One of them was the Aladdin homes. That means you could have a catalog. This is the catalog of the Aladdin homes, and this shows how the house would look from inside along with drawings of plans, etc. You could order the house, and the house as it looked like it would be presented to you in the catalog. It could be shipped on site and assembled on site. The parts were all prefabricated and assembled on site. The other idea was by Buckminster Fuller, which did not really take off. It was only an idea of the Dymaxion house designed by Fuller in the 1920s. It was aimed for production and efficiency, but it remained only as a concept. But then in the mid 20th century, when a post-war boom took place, all the advantages of prefabrication they had learned during the world wars came to more consumer use in America, for example. And notable projects of a very large scale were, for example, the Levittown project. It was a township development in which there were these mass produced suburban homes in America with an assembly line technique and rapid construction. Now, here the parts were not manufactured in the factory. There were basic parts that were manufactured in the factory, they were shipped on site, and even wet work and dry work was done on site. All the workers used to come together and assemble the house in a very short time. So, the process of raising the house or building the house was like an assembly line. That means all the work would go on parallelly, where the foundation is being built or the piping is being laid out, the drainage or the electrical system is laid out. The entire process was much more streamlined. The second was the Pruitt Ego development, which was a very large public housing, though not ultimately a successful development. It was also an example of such kind of prefabricated construction. Then in the late 20th century, modular construction really took off with great advances in materials and technology, and one example is the Habitat 67 by Moshe Saabdi, which he executed in the Montreal Expo 67. And here it was a modular housing complex, a very unique design that Moshe Saabdi came up with, and it was all prefabricated. These panels, the entire units were shipped on site and put together on the site. But then it was in the 1970s, 1980s, with the appearance of high-tech architecture, that prefabrication took a completely new form. Here were these amazingly interesting, iconic buildings that were coming up with the idea of prefabrication. One was the HSBC building in Hong Kong by Norman Foster in 1985. At that time, one of the most expensive tall buildings built. During that time, it was costing about $640 a square feet of construction, probably the most expensive tall building built at the time because it was highly innovative. So, here I am not trying to connect prefabrication with cost because it was very expensive, but the idea of this building was very unique because the site of HSBC became more of an assembly site. It was not possible to build this building in Hong Kong using their technology and fabrication skills because those were not available there. Therefore, Norman Foster said that this was truly a component building with parts shipped from America, Japan, the UK and assembled on site, and it was totally prefabricated. The other thing was not only were the parts shipped from large number of countries, the consultants involved with this building, the people who were working along with this building were also from diverse countries. So, for example, the bathroom unit itself is a case in point. This unit which came up here, they were shipped from Japan and it came totally sealed, and they had everything already fitted in them. There was the disposable towels, the toilet roll holders, etc. They were shipped from Japan, prefabricated in Japan. The entire unit as is, completely sealed, was shipped on site, lifted up. This entire unit was lifted up and then plugged into the building. And now imagine the kind of quality control required, because the outlet pipes that were already installed in the building have to match accurately with the new points that were to be connected to the washroom that was coming from Japan. So, the tolerances were it was highly exact and precise construction. So, here came to highlight how precise construction or prefabrication became in the 20th century. And then this concept of prefabrication led to repetitive components being made in a factory. We will see more of this when we talk of high-tech architecture in totality, and we will look at some of the concepts and ideas proposed by these high-tech architects. So, suffice to say here that they were repetitive components made in a factory, they were more precise and more economical, and some of the finest buildings of the time that came up under the high-tech architecture were using prefabrication and modular coordination. Now, please understand this. These prefabricated parts are not like the other prefabricated parts in areas of technology and engineering, because here the parts are more specific to a building. For example, Lloyds of London by Richard Rogers in 1978, their parts were specifically designed and fabricated which were meant for the Lloyds building. That is one what you would call a standout feature in architecture, which is not so in engineering, because in engineering the parts that are manufactured, for example, let us take the example of chips. Now these chips that are to be used in millions of phones are manufactured en masse, and then they are installed in wide variety of phones of different brands. That is not doable in architecture, where the prefabricated parts are more connected to one particular building. For example, HSBC would have its own parts, Lloyds would have its own parts. But over time, one thing that happened was that some of these parts, like let us say the handrails or some of the other units that were fabricated for a particular high-tech building, could have become usable in more buildings. Other buildings could have used a similar or the same kind of design, and they could have been prefabricated in larger numbers. Therefore, but one thing definitely happened, that the building process became more precise and more economical because there was less wastage. The parts were more precisely designed, manufactured in the factory, and they could be done using machines rather than hand. There were new design methods to rationalize details, understand structure as an assembly of carefully engineered parts. Then there is the Renault Distribution Centre in Swindon in 1982 by Norman Foster, which is a 25,000 square meter building, and in this building comes really the what you would call the strength of prefabrication and modular construction, because this particular building is one unit, one modular composite unit that is multiplied over many times. Now this kit of parts, this entire is a complete kit of various parts, is similar to the idea of Meccano. You might have heard of Meccano. Meccano was a toy which was manufactured in end of 19th century, but it was quite popular in the 20th century, and this was a toy which had a set of parts that was provided within it, and children could use these metal strips, plates, girders, wheels, ankles and gears and put them together in kind of various machine kind of toys like this one here, and nuts and bolts, screws, everything was provided, and these were actually, you could make working models and mechanical devices with Meccano. Now the idea of Renault is similar to that. It has the kit of several parts. So there are these 42 square modules. Within each of these, this is one module. Each of this, there are about 42 square modules, 24 meter by 24 meter. Each module has a PVC membrane roof that you see here, and it has this arch steel beam here, that is held by these tie rods, and the tie rods then transfer their load to the column here. So this or the mast here. So this entire structure is very simple and it is multiplied all through this. So the strength of prefabrication modular construction became quite obvious in structures like this. There were other buildings made of the similar type. We will see later. There was the Schlumberger Research Center made by Michael Hopkins, and we will see that example later. Now the other advantage of modular construction was it was able to provide very large flexible open space, column free space, and this became important for Renault because this was supposed to be for racking, warehouse racking and storage, and also whenever they would require to change the configuration inside the building, it could be done very easily. This concept became very important in the 20th century. Now as prefabrication moved forward all the way into the 21st century, now the focus is more on sustainability and energy efficiency. The prefabricated components not only minimize waste, not only reduce construction time, but they also lead to better environmental performance because there is less wastage of material, the production itself is more efficient, leading to energy efficiency and thus better environmental performance. These high performance buildings using this kind of prefabrication are, for example, the Shard by Renzo Piano in London, or the Apple Park in Cupertino, the headquarters of Apple, designed by Norman Foster. And all the way into the 21st century, if we look what is going to be the future of prefabrication, then It is in 3D printing and advanced manufacturing technologies which are revolutionizing this concept. For example, the world's largest 3D printed building has come up in Dubai. It's not a very big structure, it's just a two-storied structure, but the entire buildings or components in a 3D printed building can be manufactured off-site, the larger pieces, and a large part of the construction can also be done on-site. It can be 3D printed on-site, and so you can print the large parts in a factory, assemble them on-site, or you can continue in a very harmonious way on-site building the walls, for example, with large 3D printers. So this customization and efficiency is what we are looking in the days ahead in the future. What other lessons besides prefabrication, modular construction, efficient construction, less waste of materials, economy of scale and time, what more can we learn from, or what other ideas were derived from the Crystal Palace? For example, the cross bracing. Cross bracing is to resist lateral loads that come from high winds or from earthquakes, and this became an important aesthetic and a structural feature in modern buildings. For example, you find the idea of cross bracing being used here in the Crystal Palace, and then you find that being used here in the Centre Pompidou. So the Crystal Palace itself had the idea. It was a massive structure, very lightweight structure in iron and glass. Thus the cross bracing, to resist lateral loads that will come upon it, the idea was used in the modern times. And there are other buildings that came up, as you see here in these buildings, the idea of cross bracing in high-tech architecture. Then the idea of lightness and transparency. One of the things that became the highlight of the Crystal Palace was how light and transparent the building was. The heavy masonry structure there was no such heavy masonry at all. Completely light and transparent structure, which has now become a very important part of modern architecture. And for example, the Pompidou or various other buildings. For example, transparency in the Richard Rogers building, the 88 Wood Street building, as you see here, how tremendously light and transparent the building looks. Now, transparency not just because of glass through and through, transparency also in the way the overall structure is transparent. If you look at the Centre Pompidou, for example, and we will see the pictures later, the entire structural frame within the building inside is transparent and colored with primary colors. So transparency is not only in the glass, transparency is even in what is encased within the glass, the staircase, for example, here, or even the pipes running within the building. They are all made transparent, more so in some other buildings we will see later when we study high-tech architecture. So here is the Lloyd's Register of Shipping in London by Richard Rogers, again an example of this transparency. And we see massive amount of transparency in our airports. And again we look at the example where the airport started changing. The major change of modern airports happened with the Stansted Airport by Norman Foster, and we will look at that later hopefully, where the concept of being able to see the flights take off and land had disappeared as airports were coming up and they were becoming more and more bulky. And Norman Foster tackled the idea with the Stansted Airport being a single envelope airport, and now when you were in the departure lounge you could actually see the pleasure of aircrafts, you could have the pleasure of seeing aircrafts take off and land, which everybody. So now all airports consistently have that. They have a huge single envelope. There is a massive amount of freedom of space. It is just one massive enclosure, and the amazing amount of transparency all airports have. They use massive amount of glass all around and make the structure as light and transparent as possible. You could that is what airports are like today. Even in India, for example, in the T3 in Delhi or the Mumbai airport, all the airports in India follow the same light and transparent single envelope format, and that is true globally. The other idea that came through from Crystal Palace was the idea of large column-free enclosures or column-free spaces. So you find that in the HSBC, you find that in the Lloyd's, you find that in the Pompidou, borrowed from the Crystal Palace. Now, one more thing we learned from 19th century, and we saw the barrel vault in the Crystal Palace, these vaults of iron and glass, and we talked about it last time also, how this became so important, for example, in department stores, where now shopping could be done in adverse weather also. You could shop at night with gas lights on. The entire shopping experience became different. I talked about it in my last presentation. So here also we have vaults in iron and glass, and now we have modern steel and glass vaults that we see in our shopping malls, for example, in our railway stations, etc. And here in the airport of Beijing T3 terminal, you have this massive glass vault. You can see it also from the outside, and it is being used in this airport. Glass and steel enclosures, not just vaults, have become more and more visible in the 20th century. And here we have massive buildings, very light, very transparent, with these massive enclosures. For example, the Javed Center that you see here, this is from the inside, or the Garden Grove Community Church you see is completely in sleek glass. We will talk about slick tech architecture later on when we talk of late modernism, and this is how this massive glass and steel enclosure looks like. All these ideas are crystallizing from the 19th century. Now here I would like to say, not just from the Crystal Palace, but even the vaults, the iron and glass vaults being used over over the railway tracks. These ideas of the way you could use glass and steel over in massive enclosures was coming from there. And now we have the Changi Airport, the T3 Singapore, or the Glass Pyramid in Paris, or the Gardens of the Bay in Singapore, or this is the top floor completely domical glass and steel enclosure over the Gherkin building. It is a restaurant right at the top, and hopefully we will look at this building in more detail. But again, the how much application of glass and steel enclosures in modern architecture. Now diverting a little, let us look at another exhibition that happened, which happened in 1889. The one in which the Crystal Palace, the great exhibition, was 1851, 1853, and then the Paris exhibition, the World Fair, was in 1889, and it again gave rise to a completely new architectural form, the tall steel structure, and that was the Eiffel Tower. Now the entire complex had two major parts in it. Of course, there was the Eiffel Tower, which formed the entrance to the World Fair, and behind it was a massive enclosure in glass and steel, or iron and glass, which was the Hall of Machines. In order to understand the scale, look at this picture very closely and you will see these humans here. And now you understand this scale is monumental. So the Eiffel Tower, which was designed, executed by Gustave Eiffel, who was primarily an engineer, it is a cross-braced lattice structure to minimize not only material use but also wind resistance, with over 7,000 tons of high quality wrought iron. It was a masterpiece of wrought iron technology. So the Hall of Machines was on a monumental scale, 427 meters long, 45 meters high, with a span of 114 meters. A huge structure that was erected in wrought iron and glass. In conclusion, what do we learn from the advancements of the Industrial Revolution? Definitely, it was a major force for idea of a modern architecture. Please understand, this is the foundation being laid for modern architecture. The buildings that we have seen, Pancras Station, the Exchange buildings, etc., having an eclectic form or a classical form, do not indicate what finally modern architecture became, but in that was the kernel or the root of the idea, the seed of the idea that was to then come in modern architecture. But the importance of these structures, this architecture in iron and glass was that there was new materials and methods of construction with new solutions and new forms, and for the first time there was a split between architecture and engineering, because now the buildings were becoming much more structurally complex, and the old way empirically constructing buildings was no more possible with iron construction. We have talked about it earlier also. Industrialization led to the creation of new building types, shopping malls, railway stations, exchange buildings, even skyscrapers, tall buildings in Chicago, and we will talk about it. These buildings had no precedent, so the architects had to rapidly evolve themselves with this fast evolving technology and materials. Mechanization disrupted the world of crafts and hastened the collapse of vernacular traditions. We will talk about it more in the next presentation. Industrialization also led to the new economic structures and new centers of power. Though patronage of architecture till 18th century Europe was principally the state, religion and aristocracy, but now increasing reliance was on wealth and aspirations of the rising middle classes. So architecture became more democratic, more number of buildings could come up because wealth was distributed over a large section of society. Finally, we understand that with all these socio-economic and technological changes leading to changes in architecture, I say this: architecture is not a driver of change, but it is driven by change. It is very important for us to understand that architecture itself, though of course it is said to be the mother of arts, etc., but the principal thing about modern buildings is they are very highly technology driven, they are very highly driven by finance and the socio-economic conditions prevalent in our society. And it is very important for architects to understand these driving forces that lead to evolution of modern buildings. Of course, Winston Churchill also said, first we shape our buildings and then our buildings shape us. But please understand this, there is a need to understand socio-economic and cultural technological changes and evolution taking place, as they have a direct impact on the evolution of architecture. This is an example of what 1856 New York was, and this is what it became by 2013. We will stop here and we will continue with this in the next presentation on Art Nouveau, when we will talk about the removal or the collapse of the craft tradition and the coming in of the machine and how the machine led to further evolution of architecture. Thank you.